dy equals 29 dt, because when I differentiate this, I get the differential of y is 29 dt. Okay, and then I know that I have dt here. I don't have 29. That's not a problem. I can multiply and divide by 29. And now this and this make up the dy. So I have 1 over 29, the integral from e to cosine y times sine y times dy. Okay, well, that's good, but not good enough. I have one more step in which I'll say sine is nice, but cosine inside e is not that nice. So I'm going to say let u be cosine y. And when I determine the differential of u, when I differentiate cosine y, I get negative sine y times dy. Because it's du, it's not a derivative, it's a differential. So I only have to make up a negative sign, not a problem. I multiplied twice by -1. And now this piece and this piece and this piece are all together in du. So this is -1 over 29, the integral from e to u du. This is e to u. The negative and the sign and the dy make up the du. And this cannot be easier. It's just e to u plus a constant c. However, I have to go back to u. So -1 over 29 e to the constant, to the cosine y. But y was 29t, so it's 29t plus a constant c. So I applied the substitution rule twice, or I used the substitution twice. I want to post the old test just in case after we finish with the WebAssign. You may have questions from the old test. I'm not rushing you. I just wanted to have it posted. Okay, anything else from 5.4 and 5.5?
I don't think so.
Okay, so let me post the test. And please look and let me know. Okay. Almost there. My computer is a little slow. Okay. It's coming right now. Finally. Okay, it's there. I didn't rename it. Oops. My keyboard fell off.
Oh, yeah, I see it.
It says fail to create. Do you see it? Okay.
Yeah.
Yeah, so I'm gonna rename it test 4. Okay. Good. So I have it open. Take a look and let me know if you have any, if you want to work on anything, if things will be different because of WebAssign. And remember, for all definite integrals, we have to check that the function is continuous on the given interval. If it's not, fundamental theorem of calculus. So for example, if I'm asked to find the integral from -3 to 4 from 1 over x dx, the function is not continuous at 0, and 0 is in this interval, I would say fundamental theorem of calculus is not applicable. This is for Calc 2, and it's called an improper integral.
Can you do number 1?
Yes, of course. On this test that I posted, right?
Yeah.
Okay, let's take a look. Number 1. Very good. So in number 1, we have an acceleration function, 10 sine t plus 3 cosine t. And they're asking us to find the distance function. And they're giving us that s of 0 is 0 and s of 2 pi is 12. So we're not asked to find the most general antiderivative. They're specifically asking us to find that function that has the second derivative this. And when I plug in 0, I get 0. When I plug in 2 pi, I get 12. Okay. So first I have to find the velocity function. 10 is 10. Which function prime is sine t? And that will be negative cosine t. Again, 3 is 3. Which function prime is cosine? And that would be sine t plus a constant c1. I don't have any information about the velocity. I have to continue because I don't have any condition to plug in here. There is nothing given about the velocity. So now I continue finding the antiderivative of the velocity, which is the distance formula. Negative 10 is negative 10. Which function prime is cosine? Well, it's sine. And then which function prime is positive sine? Well, it's going to be negative cosine t. Because when I differentiate cosine, I get negative sine with minus in front, and I get this. but now plus C1t and plus C2. C1t prime is C1. C2 prime is 0. Any questions so far? Is this okay? Okay, so the next step is I have to plug in 0 because I'm given that S of 0 is 0. Sine 0 is 0, so this is 0. Cosine 0 is 1 times negative 3. This will be 0, and then plus C2 equals 0. Therefore, C2 equals 3. I will plug in 3 and write S of t as negative 10 sine t minus 3 cosine t plus C1t and plus 3. Now I need to determine C1, and I'm given an extra condition. S of 2 pi equals 12. So then when I plug in 2 pi in here, this is still 0. When I plug in 2 pi, this is 1 times negative 3. When I plug in 2 pi here, I have plus 2 pi C1 plus 3 equals 12. These two go away. So then C1 equals 12 over 2 pi, or 6 over pi. And now I'll go back and plug it in. So the unique function that is the distance formula, or distance function, is negative 10 sine t minus 3 cosine t plus 6 over pi t plus 3. Is this okay?
Yeah, that's great.
Very good. Is there anything else you would like to look at?
Number 3.
Number 3 it is. Now let's see what number 3 is asking us to do. Why is my computer so slow? Number 3. Yes. So we're given, we're asked to find the integral. Is this the one, 0 to 5 from f of x dx?
Yes.
Okay. So we're given a function that is a piecewise defined function. So e to the x plus 3x if x is less than or equal to 3, and the square root of x if x is greater than 3. And remember, there is a property of the definite integral. When I calculate from 0 to 5, in this case from 0 to 3, I can split it into two. Oops, I didn't mean that. I meant this. So we split it into two integrals, and we have to add them up. One from 0 to 3, y3 because this is 3, and the other one from 3 to 5, y5 because I only have between 0 and 5. Between 0 and 3 from this function, e to the x plus 3x dx, and 3 to 5 from this function, the square root of x dx. I didn't have to put them in that little corner there. So therefore the integral from 0 to 5 from f of x dx will be the antiderivative of e to the x is e to the x plus 3x will be 3. I increase the power and I divide by that exact number from 0 to 3 plus this is x to 1/2. So I will write x to 1/2 plus 1, which is x to 3/2 over the same number. And this time from 3 to 5. So now for the first integral, I will plug in 3. So this is e to the 3rd plus 9 times 3, 27 over 2. When I plug in, careful, when I plug in 0, this becomes 1. So minus 1, but this is 0. And then plus 2 over 3. I plug in 5. 5 to 3/2 and subtract 3 to 3/2. And I recommend leave it as is. There is no need to, that's what I wrote, do not perform the final calculations. I don't need the arithmetic on this. Is this okay?